Hi students, my name is Dr. M. Abdul Rahman, working as Associate Professor of Chemistry, Department of Collegiate Education. This is the video for the session number 15. This is the last video of the topic, that is analysis of water. The one of the topic included in the basic analytical chemistry paper of 5th semester BSc University of Mysore. Here I am going to discuss about the determination of dissolved oxygen of a water sample. In the earlier video, that is session number 14, I discussed the determination of pH, acidity and alkalinity of the water sample. Here I will discuss how we can determine the dissolved oxygen of a water sample in the laboratory. The video consists of the principle, reagents, procedure, reagents required for the analysis, and procedure and calculations. The dissolved oxygen, the principle involved here, the dissolved oxygen forms the basis for biochemical oxygen demand, which is an important parameter to evaluate the organic waste in water samples. The principle involved in the determination, the chemical reaction takes place, is the manganese sulfate, because the reagents we are using here, manganese sulfate solution and alkaline potassium iodide solution. This solution of potassium, sodium azide, potassium iodide and sodium hydroxide in water. You can also take here sodium instead of sodium hydroxide, potassium hydroxide also you can take, and constant sulfuric acid and 0.25 normal sodium thiosulfate solution and starch as indicator. And the principle, in this principle, the chemical reaction taking place is manganese sulfate reacts with potassium hydroxide or sodium hydroxide, it gives manganese hydroxide. And this manganese hydroxide reacts with the oxygen to form basic manganic oxide. Basic manganic oxide, here the oxygen state is of manganese is +4 and here it is +2. It's oxidized to +4. Then this basic manganic oxide then releases nascent oxygen, and thereby it reduces from +4 to +2, releasing oxygen. This nascent oxygen reacts with the potassium hydroxide, liberates iodine, and this liberated iodine is made to titrate. It is titrated against sodium thiosulfate solution using as a starch indicator. The amount of nascent hydrogen liberated, that is almost equivalent to the amount of hydrogen liberated in this reaction. So liberated iodine is titrated against sodium thiosulfate using starch and indicator. Thereby we can determine the amount of dissolved oxygen present in the given sample. These are reagents are already discussed. And the procedure. In this procedure, the laboratory procedure is pipette out 200 ml of water in a glass stoppered bottle, add 2 ml of manganese sulfate solution followed by 2 ml of alkali iodide azide reagent. Mix it well and allow the precipitate to settle. Add 2 ml of concentrated sulfuric acid, 2 ml of concentrated sulfuric acid to dissolve the precipitate. Titrate the liberated iodine against standard sodium thiosulfate solution using starch as indicator. So that means first you have to pipette out 200 ml of water sample in a stoppered bottle, and we have to add 2 ml of manganese sulfate solution followed by 2 ml of alkali iodide and azide reagent. Sodium azide is used to remove the nitrites present in the sample. Mix it well and allow the precipitate to settle. Then we have to add 2 ml of sulfuric acid to dissolve the precipitate. And on dissolving the precipitate, it liberates iodine. That is a reaction with sodium reaction with the sulfuric acid with the potassium iodide in presence of nascent hydrogen. It liberates iodine, and that liberated iodine is titrated against sodium thiosulfate solution taken in the burette. The calculation part here is the dissolved oxygen. How we can calculate the normality into volume of oxygen solution, that is equal to normality into volume of sodium thiosulfate solution. So normality, that is N1 V1 is equal to N2 V2. So normality of, now we want normality of oxygen solution, that is equal to normality into, this normality into volume of sodium thiosulfate divided by volume of oxygen solution. So that is equal to N is the normality and V is the volume of sodium thiosulfate consumed in the titration divided by volume of the sample taken, that is 200. Let suppose this value is equal to A. If it is A, then the mass of dissolved oxygen per dm cube per liter of the sample, that is called normality into equivalent mass of oxygen. So A into 8 into, that is per liter, is the 1000 milligram per dm cube. So in this way you can calculate the dissolved oxygen present in the given sample. So for more you can refer the books like Engineering Chemistry by Jain and Jain and Instrumental Methods of Chemical Analysis by Gurudev Parchatwal and Anand. Chemistry for Engineering Students by Dr. B.S. Jaiprakash, Professor R. Venugopal, Dr. Shivakumaraya and Pushpa Iyengar. So in this way we can determine the dissolved oxygen of the given sample. Thank you.